Welcome to this deep dive
Right.
into the world of building construction.
Mm.
We're going to try to understand how those buildings up to 3 stories high get put together.
Okay.
And we've got a blueprint bonanza to guide us. We've got building codes, engineering textbooks, even some Australian standards
Yeah.
thrown in for good measure.
Just shebang.
Exactly. So our mission today is to give you the knowledge to understand not only the core structural principles,
Right,
but to
yeah.
be able to spot those potential construction issues.
Okay.
Oh, and of course, we'll sprinkle in some fun facts about building materials along the way. Ready to start laying the foundation, both literally and figuratively.
Let's dig in.
Okay, so whether you've, swung a hammer before or are just curious how those walls stay up, we have to start with the fundamental structural principles. Imagine a family moving into a brand new home, furniture, appliances, maybe even a few rambunctious kids.
Oh, yeah.
That house is facing dead loads, its own weight, live loads from the family's belongings, and environmental loads like wind or snow.
That's a great way to put it.
Okay.
And to handle all those forces, a building needs those core principles you mentioned. Strength, stability, and serviceability. Think of it like a well-choreographed dance.
Okay.
Each principle has its role to play, and if one falters, the whole performance is at risk.
All right, so let's break down these dance moves. What does each principle actually mean in the context of keeping a building intact and upright?
Strength is the building's ability to withstand those loads we just talked about. It's about making sure the materials and structural elements don't buckle under pressure.
Oh.
Stability is all about preventing the building from tipping over, sliding, or collapsing, making sure it stays firmly planted on the ground no matter what external forces come into play.
So strength is like the building's muscles and stability is its sense of balance.
Exactly.
Yeah.
And finally, we have serviceability. This ensures the building functions as intended, that it doesn't sag, crack excessively, or become uncomfortable for the occupants. Things like doors and windows operating smoothly, floors feeling solid underfoot, those all fall under serviceability.
So it's not just about surviving, it's about thriving as a functional space
Right.
for people to live and work in.
Precisely. And here's where it gets interesting. These three principles are interconnected.
Okay.
A weakness in one can impact the others, potentially setting the stage for building failures.
Yeah, that makes a lot of sense. We'll definitely dig into those failures later, but first I'm curious about how engineers figure out the impact of those loads on different building materials. It sounds like there's some serious physics at play here.
Oh, it's all about the physics, you're right.
Mhm.
One way to understand this impact is through the concepts of stress and strain.
Okay.
Imagine you're holding a wooden ruler.
Okay.
When you apply force to bend it, you're creating stress within the ruler's material.
Okay, I can picture that.
The amount the ruler bends is the strain.
Hmm.
The more force you apply, the higher the stress and the
Yeah.
strain. And just like that ruler will eventually snap if you bend it too far, building materials have their limits too.
Right.
Engineers use units called kilopascals, kPa, to measure stress and to describe the strength of materials like steel and concrete.
So kilopascals are like a way to measure how much stress a material can handle before it says enough is enough?
Exactly. And different materials have different strengths. That's why choosing the right material for the right structural element is crucial. It's like casting actors for a play. You wouldn't choose a lightweight actor to play the role of a weightlifter, would you?
No, that wouldn't end well. So we've got our loads, our stress, and our strain. Now, how does this all translate into the different parts of a building?
It's all about load transfer, a carefully orchestrated chain reaction
Okay.
from the rooftop down to the very ground the building stands on. To understand this, think of a building like a tree.
Okay.
You have the superstructure, the visible part above ground, like the tree trunk and branches.
Mm-hmm.
And then you have the substructure, the hidden network of roots, anchoring the tree and providing stability.
That's a great visual. So the superstructure is all about the living spaces, while the substructure is the foundation that keeps it all from toppling over.
You got it. And within both the superstructure and the substructure, each element plays a crucial role in transferring that load effectively.
All right, so let's walk through this load transfer process. Where does it all begin?
It starts at the very top with the roof. Whether it's made of trusses, slabs, or decking, the roof takes the brunt of the environmental loads like rain, wind, and snow.
Okay.
It then passes this load onto the beams.
And beams are those horizontal structural members, like the backbone of the floors and the roof, right?
Exactly. They support the weight from above and transfer that load horizontally to the columns. Think of beams like bridge supports,
Okay.
carrying the weight of the roadway.
Okay, so the beams are the horizontal heroes.
Yeah.
And what about those vertical supports, those columns?
Columns are like the pillars holding up the roof and floors.
Mm-hmm.
They take the load from the beams and channel it down to the foundation. They're designed to handle massive compressive forces, preventing the building from being crushed under its own weight.
I'm starting to appreciate the teamwork involved here. Each element has its specific job, and they all work together seamlessly. And what about those wind bracings I keep hearing about? Are they a part of this load transfer system as well?
Absolutely. Wind bracings are essential for resisting those lateral forces we talked about earlier, the sideways push from wind.
Right.
Imagine those powerful gusts trying to tip over a building like a giant domino.
Yikes, not a good scenario.
Exactly. Wind bracings, like those diagonal steel members you often see in buildings, help to counteract those forces and keep the structure upright.
Okay.
You transfer the wind load to the columns and then down to the foundation.
So they're like the building's safety net, preventing it from swaying too much in those strong winds. What happens when the load reaches the substructure?
That's where the footings come into play.
Okay.
They're the unsung heroes, often hidden underground, but crucial for distributing the load from the columns over a wider area of soil. Think of footings as the building's feet, spreading out the weight to prevent sinking or uneven settling.
So they're like snowshoes for a building, preventing it from sinking into soft ground.
That's a great way to put it.
Mm.
And the type of footing used depends on the soil conditions and the load from the building. Some soils are like rock, strong and stable. Others are more like sand, requiring a broader base for support.
And then beneath the footings, we have the foundation itself, the ultimate anchor holding the whole building in place, right?
Exactly. The foundation transfers the entire load of the building to the ground, ensuring stability for years to come.
Okay.
It's like the bedrock of the entire structure, and getting it right is absolutely essential.
Speaking of the ground, what about retaining walls? I know those are part of the substructure too, but they seem to have a slightly different function.
You're right. Retaining walls are all about holding back earth where there's a change in elevation, like a hillside or an excavated basement. They prevent the soil from collapsing and creating a landslide, ensuring the stability of both the building and the surrounding ground. They're like the guardians of level ground.
So retaining walls are essential when nature's terrain doesn't quite cooperate with our building plans.
Exactly. They create a stable platform for construction and prevent those unwanted surprises that Mother Nature can sometimes throw our way. And the type of retaining wall used depends on the height of the earth being retained and the forces it's pushing against. Some rely on their own weight, while others use reinforcements like steel or anchors for extra strength.
Wow, so much thought goes into making sure those walls stand firm. Now I'm eager to dive into the materials themselves. What are some of the building blocks that give a structure its character?
Let's explore the world of concrete, steel, timber, and even those fascinating composite materials. Each one has its own unique properties and advantages, making the selection process a bit like choosing the right ingredients for a delicious recipe.
Okay, I'm ready to explore this material menu. What makes each material stand out?
Concrete, for instance, is incredibly strong under compression. Think of those massive concrete pillars supporting bridges and skyscrapers.
Right.
They can handle enormous weight pushing down on them.
Yeah.
But concrete has a weakness. It's not so great at handling tension, those pulling forces.
Okay.
That's where steel comes in, offering incredible tensile strength.
Ah, so concrete and steel are like the perfect construction couple.
Precisely. That's why you often see them working together in reinforced concrete, where steel bars or mesh are embedded within the concrete to boost its tensile strength. It's a dynamic duo that combines the best of both worlds.
And what about steel on its own? I know it's a popular choice for skyscrapers and bridges.
Steel is known for its high strength-to-weight ratio. It can handle massive loads while being relatively lightweight,
Okay.
making it ideal for spanning long distances and creating soaring structures. But steel has its Achilles heel.
Right.
It's susceptible to fire and corrosion,
Right.
so it often needs a protective coating or a concrete encasement to shield it from the elements.
So steel is strong but needs a little bit of pampering
Little TLC.
to stay in top shape. What about timber? I love the look of timber framing, but is it as structurally sound as concrete or steel?
Timber might surprise you. While it might not be as strong as steel in pure tensile strength, timber has an excellent strength-to-weight ratio,
Okay.
making it surprisingly capable for its weight. And here's a bonus. It's a renewable resource, making it a sustainable choice for construction.
That's fantastic. So timber brings both strength and sustainability to the table.
It does.
What about those composite materials you mentioned earlier? Are those like the superfoods of the building world?
You could say that. Composite materials combine the best of different materials to create something even stronger and more versatile.
Okay.
One great example is steel concrete composite construction, where steel beams and concrete slabs work together to create incredibly strong and efficient flooring systems. It's like a power couple in the construction world.
Interesting. So composite materials are all about teamwork and maximizing the strengths of different materials. I'm starting to see why they're becoming more popular in modern construction.
Exactly. And in Australia, there are specific standards like ASNZS 2327, which provide guidelines for the design and construction of composite steel and concrete structures.
Okay.
These standards ensure that these innovative materials are used safely and effectively.
So it's like having a recipe book for composite construction,
That's a good way to put it.
making sure the ingredients are combined in just the right way.
With so many materials to choose from, how do builders decide which one is right for a particular project?
It's a balancing act, considering factors like cost, availability, the building's purpose,
Right.
and the local climate. You wouldn't choose timber for a building in a termite-prone area, would you? Definitely not. That sounds like a recipe for disaster. So it's about carefully weighing the pros and cons of each material and choosing the one that best fits the project's specific needs and challenges. But how do architects and engineers actually communicate all of this information to the construction team?
That's where those blueprints come in, the language of construction.
Okay.
They're packed with symbols, abbreviations, and detailed drawings
Right.
that guide every step of the building process.
Okay, time to put on our architect hats and try to decipher those construction plans. I'm sure they're full of all sorts of intricate details. Where do we even begin?
A good starting point is understanding the different types of plans. Think of it like exploring a city. You have your street map showing you the layout of roads and buildings.
Okay.
That's like the foundation plan, showing the footprint of the building and where it connects to the ground.
Okay.
Then you have those detailed maps that show you the inside of buildings, the room layouts, the locations of doors and windows.
Right.
Those are like the floor plans, giving you a bird's eye view of each level.
Okay, I'm starting to see how it all comes together. So the foundation plan is like the building's roots, and the floor plan is like its internal anatomy.
Exactly. And just like exploring a city, we need different perspectives to fully understand a building. That's where elevation views come in.
Okay.
They're like those panoramic photos you take from a high vantage point, showing you the building's facade, the roof line, the placement of windows and doors, the building's personality, so to speak.
Ah, so elevation views are like the building's portrait, capturing its unique style and character?
Precisely. And to complete our architectural tour, we need to delve into the building's inner workings. That's where section views come in.
Okay.
Imagine slicing through the building like a cake and seeing all the layers, the floors, the walls, the ceilings, the roof.
So section views are like those anatomical cross-sections you see in biology books, revealing the hidden structure beneath the surface.
Exactly. They give us a detailed understanding of how the building is put together vertically, from the foundation up to the rooftop.
All right, I'm feeling much more confident about navigating those blueprints now. But before we move on, I want to circle back to something we discussed earlier, the importance of understanding soil conditions. It sounds like getting a soil checkup is just as important as getting a building permit.
You're absolutely right. The soil is the unsung hero of any construction project. It's the foundation upon which everything else rests, and understanding its characteristics is paramount.
So how do we get to know this hidden world beneath our feet?
That's where geotechnical engineers come in, armed with their drilling rigs and soil samples.
Okay.
They're like detectives, digging deep to uncover the secrets hidden beneath the surface.
Okay, I'm intrigued. Walk me through this geotechnical investigation.
First, they drill boreholes at strategic locations on the site, extracting soil samples from various depths. It's like taking core samples from the earth to understand its composition and structure.
So they're literally piecing together a geological puzzle.
Exactly. Those soil samples are then whisked off to a laboratory for a battery of tests. They measure things like density, moisture content, bearing capacity, basically how much weight the soil can handle without collapsing.
Right.
It's like giving the soil a fitness test to see how much it can lift.
And I'm guessing the results of this soil fitness test determine what kind of foundation the building needs.
Absolutely. If the soil is strong and stable, a simple, shallow foundation might be sufficient.
Oh,
But if the soil is weak or prone to settling, a deeper, more robust foundation might be required.
Makes sense. It's like choosing the right shoes for a hike. You need sturdier footwear for rough terrain.
That's a great analogy. And
Hmm.
just like those hiking boots protect your feet, a well-designed foundation protects the building from sinking or shifting over time.
Speaking of protection, we can't forget about retaining walls. You mentioned earlier that they play a crucial role in holding back earth and preventing collapses, especially on sloping sites or during excavation.
Right.
But even with the best designs, things can go wrong, right?
You're right. Retaining walls strong and sturdy, aren't invincible.
Right.
They can fail if certain factors aren't carefully considered during design and construction.
Okay, that's a bit unnerving. What are some of the common culprits that can lead to a retaining wall disaster?
One of the biggest enemies of a retaining wall is poor drainage.
Okay.
If water is allowed to build up behind the wall, it can exert tremendous pressure, like a relentless wave pushing against the seawall.
So it's like a bathtub overflowing. Too much water and the walls can't hold it back.
Exactly.
Yeah.
That's why proper drainage systems are crucial for any retaining wall.
Right.
They channel that water away, relieving the pressure and keeping the wall stable.
Okay.
Another common issue is a shallow footing.
Right.
If the footing isn't deep enough or doesn't have adequate support, the wall can tilt or slide, like a poorly anchored tent in a strong wind.
Right, so it's back to that foundation again. It seems like a solid foundation is crucial for just about everything in construction.
It is. And let's not forget about the quality of materials in construction.
Right.
Using substandard materials or cutting corners during construction can compromise the integrity of the wall, making it more susceptible to failure.
Makes sense. It's like building a house of cards. If one card is weak or misplaced, the whole structure can collapse.
Exactly. And overloading a retaining wall, placing too much weight on the soil it's holding back, can also lead to trouble.
Right.
It's like asking a weightlifter to lift more than they can handle. Eventually, they'll give way.
So, vigilance and expert advice are key when it comes to retaining walls. It's better to be safe than sorry, right?
Absolutely. And it's important to be aware of the warning signs of potential failure.
Okay.
Cracks, bulging, or tilting are red flags that shouldn't be ignored. If you spot any of these, it's best to call in a structural engineer right away.
Good advice. Now let's shift gears and talk about formwork. I know it's a temporary structure, but it seems to play a pretty critical role in concrete construction.
You're right. Formwork is essential for giving shape to wet concrete. It's like a mold, holding the concrete in place until it hardens and gains strength. Think of it like baking a cake. You need a cake pan to give the batter its shape and prevent it from spreading all over the oven.
So formwork is like the concrete's temporary container, ensuring it sets into the desired shape.
Exactly. But unlike a cake pan, formwork has to withstand a lot of pressure from the wet concrete as it cures.
That makes sense. What kind of materials are typically used for formwork?
You'll see a variety of materials, from timber and plywood to steel and even aluminum.
Okay.
The choice depends on the project, its size, shape, budget, and the desired finish on the concrete surface.
So there's a lot of flexibility in formwork construction.
There is.
What are some key things to consider when designing and building these temporary molds?
Strength and stability are paramount.
Okay.
The formwork needs to be strong enough to withstand the weight and pressure of that wet concrete without bending or breaking. It also needs to be properly braced and supported to prevent any movement during the curing process. You don't want your concrete wall to end up looking like a melting ice sculpture.
Definitely not. A lopsided wall wouldn't exactly inspire confidence. What else is important?
The surface finish of the formwork is crucial because it directly impacts the final look of the concrete.
Okay.
A smooth, blemish-free formwork surface will result in a smooth concrete finish. On the other hand, if you want a textured finish, you'll need to use formwork with the desired texture.
So that's how those beautiful exposed concrete walls get their smooth, polished look. It's all thanks to the formwork.
Exactly. And let's not forget about safety.
Right.
Working with formwork, especially during assembly and dismantling, can be hazardous. Workers need proper training, clear safety guidelines, and the right equipment to prevent accidents.
Safety always comes first on any construction site. Speaking of safety, I'm curious about those alternative trenching methods you mentioned earlier, soldier beams and lagging.
Yeah.
What makes them a safer option than traditional trenching?
Soldier beams and lagging are a great choice when you need to create deep excavations in tight spaces, like in urban areas.
Okay.
They provide a sturdy support system to prevent the sides of the excavation from collapsing, which can be a major safety hazard.
Okay, I'm picturing those deep trenches they dig for foundations. How do these soldier beams and lagging work together to keep those trench walls from caving in?
Imagine a row of strong steel beams, like soldiers standing at attention, driven vertically into the ground along the sides of the excavation.
Okay.
These, the soldier beams, provide the backbone of the support system.
Okay, so far so good. And what about the lagging?
The lagging consists of horizontal timbers or planks that are slotted between those soldier beams.
Okay.
They're tightly wedged against the soil, creating a sturdy retaining wall that prevents the trench walls from collapsing inward.
Ah, I see. So the soldier beams provide the vertical support and the lagging acts like horizontal bracing, holding back the soil like a shield. It's like creating a temporary underground fortress.
That's a great way to visualize it. And the best part is that it's a temporary structure.
Okay.
Once the excavation is complete and the permanent foundation or structure is in place, the soldier beams and lagging can be easily removed.
That's fantastic. It's a much safer and more efficient way to create those deep excavations, especially in crowded urban areas.
Exactly. And in Australia, we have codes of practice, like the Formwork Code of Practice and the Excavation Work Code of Practice, that provide detailed guidelines for ensuring the safe design, construction, and use of these systems.
It's reassuring to know that there are safety nets in place, literally and figuratively. Now that we've explored the world of blueprints, soil investigations, and even temporary structures like formwork, let's roll up our sleeves and delve into the actual construction process.
Okay.
What are the key steps involved in building a structure from the very first shovelful of dirt to the final touches?
Well, before we even start digging, it's crucial to double-check everything. We meticulously review those blueprints and specifications,
Right.
making sure all the measurements and locations are spot on. This step, called setting out, is like making sure all the puzzle pieces are in the right place before we start assembling the puzzle.
Okay, so we're back to those blueprints again. They really are the guiding document for the entire project.
They are. And checking the set out means verifying the building's location, the boundaries, setbacks, ground conditions, and even the location of those underground utilities we don't want to accidentally hit with a shovel.
Right, so it's about making sure everything is positioned correctly and there are no surprises once those excavators start rolling.
Right.
What happens next?
Once the set out is confirmed, we can start digging.
Mhm.
Excavation is all about removing the earth to create space for the foundation and any below-ground structures, like basements.
So it's time to bring in the heavy machinery and start shaping the earth to fit our building plans.
Exactly. The depth and extent of the excavation depend on the building design and the type of foundation we're using. And, of course, safety is paramount. We take every precaution to prevent soil collapse, especially in those deep excavations.
Right.
No one wants to be around when a trench decides to cave in.
Definitely not. I can only imagine the chaos that would ensue. So once we have this carefully excavated hole in the ground, what's the next step?
Then it's time to lay the groundwork, literally. We prepare the base for the footings, ensuring it's level, compacted, and ready to support the weight of the entire building.
So it's like creating a solid and stable platform for the building's feet to rest upon.
Exactly. And the type of footing we choose depends on those all-important soil conditions, the weight of the building, and the structural design.
Okay.
Sometimes we use isolated footings, which are like individual support pads for each column.
Mm-hmm.
Other times we use strip footings, which are like continuous beams running along the foundation walls.
I remember our discussion about those different footing types from earlier. It's all starting to connect now. What happens after these footings are securely in place?
Then the building starts to rise from the ground up. If the building has a basement, we erect the basement walls and pour the concrete floor slab. It's like building a sturdy box within the excavated space.
So we're creating a solid, enclosed foundation upon which the rest of the building will stand.
Precisely. And once those basement walls and floor are in place, we backfill, carefully filling the space around the foundation with compacted soil.
Okay.
This creates a level grade for the ground floor and ensures that the foundation is well supported.
Okay, so backfilling is like putting the earth back where it belongs, but in a more controlled and compact way. What happens after the backfilling is complete?
Then the real fun begins. We start building the superstructure, the part of the building you see above ground.
Right.
This is where the framing goes up, the beams, columns, joists, and rafters that form the skeleton of the building.
It's like assembling a giant 3D puzzle piece by piece.
Exactly. And as we're putting this puzzle together, we're constantly referring back to those blueprints, making sure every piece is in the right place and connected securely. And of course, we're following those all-important building codes every step of the way.
Right, those building codes are like the rule book for construction, making sure everything is built to last and withstand the test of time.
They are. They set the minimum requirements for safety, durability, and accessibility, ensuring that the building is not only structurally sound, but also a safe and comfortable place for people to live and work in.
Okay, so we've got excavation, footings, basement construction, backfilling, and framing. What about those finishing touches that make a building watertight and pest resistant? I'm thinking about things like damp coursing and termite barriers.
Those are essential elements that often go unnoticed, but play a crucial role in protecting the building from moisture and those pesky critters that can cause all sorts of damage.
All right, let's dive into those unsung heroes of building protection. What's the deal with damp coursing?
Damp coursing, also known as damp proofing, is like creating a shield against rising damp.
Okay.
It's a barrier that prevents moisture from creeping up through the walls and floors from the ground below.
So it's like a moat around a castle, keeping the invading moisture at bay.
That's a great analogy. We typically install damp coursing in the walls at a certain height above ground level
Okay.
using materials like waterproof membranes or chemical treatments. It's a simple but effective way to protect the building from the damaging effects of moisture.
And what about those notorious termites? I know they can wreak havoc on timber structures. How do we protect buildings from these tiny but destructive invaders?
Termites are a force to be reckoned with, but we have ways to combat them.
Okay.
Termite barriers are a must, especially in Australia. They create a protective zone around the building,
Right.
making it much harder for those termites to breach the defenses.
So it's like building a fortress to keep those hungry termites out.
Exactly. We can use physical barriers like stainless steel mesh or concrete, which termites can't chew through.
Right.
Or we can use chemical barriers, creating a treated zone in the soil that's likely to termites. It's like setting up a minefield that those termites won't dare cross.
Wow, that's impressive. So we've got damp coursing to keep moisture out and termite barriers to keep those pesky termites at bay. What about tie downs? I remember seeing those mentioned in some of those building codes. What's their purpose?
Tie downs are all about keeping the roof from taking flight, especially during those strong winds or storms that can sometimes batter our buildings.
Okay, that sounds a bit scary. How do these tie downs prevent a roof from becoming airborne?
Tie downs are like those strong ropes that anchor a tent to the ground, preventing it from blowing away in a strong gust of wind.
Right.
They secure the building's roof structure to the foundation, resisting those uplift forces that can rip a roof right off.
So they're like giant staples holding the roof firmly in place.
That's a good way to picture it. We use a variety of tie downs, including metal straps, cables, and rods, depending on the design and wind loads in the area. And of course, we follow strict standards like AS 1684 and the National Construction Code, NTC, to ensure those tie downs are up to the task.
It's reassuring to know that those roofs aren't going anywhere, thanks to these carefully engineered tie downs. Now, before we move on to potential building failures, I want to highlight something that really stood out to me in our research. The emphasis on teamwork and the collaboration of skilled professionals throughout the construction process.
You're absolutely right. Building a structure is a team effort, requiring a symphony of expertise from a diverse group of professionals.
So it's not just about builders swinging hammers.
Not at all. We have architects, structural engineers, geotechnical engineers, builders, contractors, each playing a crucial role in bringing a building from concept to reality. It's like an orchestra, with each musician contributing their unique skills to create a harmonious whole.
All right, let's break down this construction orchestra. What are the roles of these different professionals and how do they work together to create a successful project?
Architects are the visionaries, the artists who shape the building's design. They consider the aesthetics, the functionality, the sustainability, creating a blueprint that captures the client's vision while meeting all the practical requirements.
So they're the ones who draw those beautiful plans we've been trying to decipher.
Exactly. They're the masterminds behind those blueprints, laying out the spatial flow, the room arrangements, and the overall look and feel of the building. But while architects focus on the artistic vision, structural engineers are the technical experts, ensuring the building can actually stand up and withstand the forces of nature.
So they're the ones who make sure the building doesn't collapse under its own weight or get blown over by a strong gust of wind.
Precisely. They're the guardians of structural integrity, analyzing the loads, designing the structural framework, and specifying the materials and construction methods that will ensure the building's strength and stability.
Okay.
And let's not forget those geotechnical engineers we talked about earlier.
Right, those are the soil detectives who make sure the building has a solid foundation to stand on. What about builders and contractors? Where do they fit into this construction orchestra?
Builders and contractors are the conductors, bringing all the pieces together and making sure the performance goes off without a hitch.
Okay.
They manage the construction process, coordinate the different tradespeople, and ensure that the building is constructed according to the plans and specifications.
So they're the ones who take those blueprints and turn them into a physical reality.
Exactly. They're the ones who bring the building to life, orchestrating the efforts of carpenters, electricians, plumbers, and all the other skilled tradespeople who contribute their expertise to the project.
Wow, it's amazing to see how many different people are involved in creating something as complex as a building. It really is a team effort.
It is. And communication is key to making sure this orchestra plays in harmony.
Right.
If there's a miscommunication between, say, the architect and the structural engineer, it can lead to costly mistakes and delays.
Oh, I can imagine. What if the architect designs a beautiful curved wall without considering the structural implications?
That could be a recipe for disaster. The structural engineer might have to scramble to find a way to support that curved wall without compromising the building's integrity, which could add time and expense to the project.
Right, it's much better to have everyone on the same page from the start.
Exactly. Regular meetings, clear communication channels, and a shared understanding of the project goals are essential for a successful collaboration.
Speaking of potential pitfalls, I'm eager to delve into those building failures we've been hinting at. Now that we have a good grasp of construction principles, materials, and the roles of different professionals, let's put on our detective hats and explore some common building mishaps.
All right, let's play a game of Spot the Trouble. We'll investigate those common culprits: bending and shear failures, compression failures, buckling, and settlement issues.
Okay, I'm ready to become a building detective. Let's start with bending and shear failures. Those sound pretty serious.
They can be. Bending failures occur when a structural element, typically a beam or a slab, bends or sags excessively under load. Imagine a bookshelf overloaded with heavy books. If those shelves aren't strong enough, they'll start to sag in the middle, and if the weight is too much, they could eventually snap.
Right, that makes sense. So a bending failure is like a bookshelf giving up under the weight of knowledge.
Exactly. Shear failures, on the other hand, occur when a structural element breaks along a plane that's parallel to the force being applied. Think of a stack of papers being pushed sideways.
Okay.
The papers will slide past each other.
Ah. So a shear failure is like a deck of cards being sliced in half.
That's a great way to visualize it. Both bending and shear failures can result from various factors,
Right.
from design flaws and overloading to using the wrong materials or cutting corners during construction.
So it's back to those core principles again: strength, stability, and serviceability. If any of those are compromised, you're setting the stage for potential failure.
Precisely. Now, let's move on to compression failures.
Okay.
These happen when a structural element, typically a column, is crushed or collapses under a compressive load.
Okay.
Think of a concrete pillar supporting a bridge.
Okay, so compression is like squeezing something from both ends, right?
Exactly. Columns are designed to withstand those compressive forces, but if the load exceeds their capacity, they can buckle or crumble.
Okay.
This can happen if the column isn't strong enough, if it's poorly constructed, or if it's subjected to an unexpected load, like during an earthquake.
So it's important to make sure those columns are super strong, especially in earthquake-prone areas where those sudden jolts can put immense pressure on a building's supports.
Absolutely. Now, buckling is a type of failure that can occur in slender structural elements, like columns or beams, when they're subjected to those compressive forces.
Buckling, I'm not familiar with that one. What does that look like?
Imagine a thin metal ruler being compressed from both ends.
Okay.
Instead of simply shortening, the ruler will buckle outward, losing its straight shape.
Ah, I see. It's like trying to compress a drinking straw from both ends. It bends outward instead of staying straight.
Exactly. And buckling can lead to sudden and catastrophic failure because the structural element loses its stability and can no longer support the load.
So it's like a stability meltdown.
That's a good way to put it. Engineers consider something called the radius of gyration when designing columns to prevent buckling.
Okay.
Think of it this way. A wider column, with its material spread further from the center, is less likely to buckle under pressure.
So it's like spreading out the weight to create a more stable base, much like those footings we talked about earlier.
Exactly. It's all about distributing the load effectively to prevent those structural meltdowns. Now, let's shift our focus to settlement issues. These occur when the ground beneath a building settles unevenly, causing the foundation to move or crack.
Settlement, Isn't that a normal part of construction? Doesn't the ground always settle a bit over time?
You're right, some settlement is expected and accounted for in the design. However, excessive or uneven settlement can be a major problem, causing cracks in walls, sticking doors and windows, and even unsettling sloping floors that make you feel like you're walking on a ship's deck.
Okay, so what causes this excessive settlement that turns a house into a funhouse?
It can stem from a variety of factors, from poor soil conditions and inadequate compaction of the backfill to changes in the moisture content of the soil, or even vibrations from nearby construction activities.
So it's like the ground beneath the building is restless and shifting, which can put stress on the foundation and the entire structure.
Exactly. And if those settlement issues aren't addressed, they can lead to structural damage, making the building unsafe to occupy.
So what can be done to remedy these settlement issues? Is it possible to tame that restless ground?
If we catch it early on, there are ways to mitigate the problem. Underpinning is one option. Strengthening and supporting the existing foundation by extending it deeper into more stable soil or rock.
Okay.
It's like giving the building deeper roots to anchor it more securely.
So it's like a foundation transplant, giving the building a more stable base to stand on.
Exactly. Another option is grout injection, where we inject a special mixture of cement, sand, and water into the soil to fill those voids and make it more stable.
Okay.
It's like giving the soil a shot of vitamins to boost its strength.
That's a great analogy. It sounds like we have a few tools in our arsenal to combat those pesky settlement issues. We've covered a lot of potential building failures, from bending beams to buckling columns to sinking foundations. It's a bit daunting to think about all the things that can go wrong, but it's also reassuring to know that there are experts and procedures in place to address these issues.
Absolutely. Building codes, engineering principles, and those skilled professionals we talked about earlier are all working together to ensure our buildings are safe, durable, and resilient.
And as you mentioned earlier, awareness is key.
It is.
By understanding these potential pitfalls, we can be more vigilant in spotting the early warning signs and taking swift action to prevent a minor problem from becoming a major headache.
Exactly. And remember, if you ever have any concerns about the structural integrity of a building, don't hesitate to call in a qualified professional. They can assess the situation, provide expert advice, and recommend the best course of action.
Sound advice. It's always better to err on the side of caution when it comes to building safety. Now, let's switch gears a bit and talk about those essential services that make a building functional, the plumbing and electrical systems.
Ah, yes. Those behind-the-scenes networks that we often take for granted, but that are essential for modern living.
Exactly. They might be hidden behind walls and ceilings, but they play a crucial role in delivering those essential services that make a building habitable.
You're right. Plumbing and electrical systems are the lifelines of a building, providing us with clean water, sanitation, and the power to light our homes and run our appliances.
Right?
And just like those structural elements we've been discussing, these systems are governed by building codes and standards to ensure their safety and functionality.
Okay, let's start with plumbing. What are some of the key things to consider when designing and installing plumbing systems in a building?
First, we need to identify the source of water.
Okay.
Will it be a municipal water supply, a well, or a rainwater harvesting system?
So we need to know where the water is coming from before we can start designing the network of pipes and fixtures that will deliver it throughout the building.
Exactly. Once we have the water source figured out, we design the distribution system, including those pipes, valves, and fixtures that carry water to every sink, toilet, shower, and bathtub in the building.
So it's like designing a miniature water park within the walls of the building.
You could say that.
Yeah.
And just like a water park has different types of slides and pools, a plumbing system has different types of pipes for different purposes. We use different pipes for cold water, hot water, and drainage, each designed to handle the specific pressures and temperatures of its contents.
Right. You wouldn't want to use the same pipe for your drinking water and your sewage. That would be a recipe for disaster.
Definitely not. And speaking of sewage, we can't forget about the drainage system, which carries wastewater away from the building and into the sewer system, or a septic tank.
So it's like a one-way street for wastewater, making sure it exits the building safely and efficiently.
Exactly. The drainage system is just as important as the water supply system, preventing leaks, blockages, and those unpleasant backups that no one wants to deal with.
Right. A sewage backup is definitely not on my wish list. And of course, we need those fixtures, sinks, toilets, showers, and bathtubs,
Yes.
all carefully installed and connected to both the water supply and drainage systems.
Exactly. Those fixtures are the points where we interact with the plumbing system, and they need to be both functional and aesthetically pleasing.
So the plumbing system is like the circulatory system of the building, bringing in fresh water and carrying away waste.
That's a great analogy. And just like our own circulatory system needs regular checkups, a building's plumbing system needs regular maintenance to ensure it stays in tip-top shape.
Good point. A little preventative maintenance can go a long way in preventing plumbing headaches down the road. Now, let's switch over to the electrical side of things. What are some of the key considerations for designing and installing those electrical systems that power our modern lives?
Well, just like with plumbing, the first step is to determine the source of power.
Okay.
Will it be the main power grid, a generator, or perhaps a solar panel system for those who want to harness the power of the sun?
So we need to know where those electrons are coming from before we can start wiring the building and bringing light and power to every corner.
Exactly. And once we have the power source figured out, we can design the distribution system, the electrical panel, the circuit breakers, the wiring, outlets, and switches that deliver electricity to every light fixture, appliance, and device in the building.
So it's like designing a network of electrical highways, carrying those tiny but powerful electrons throughout the building.
That's a great way to visualize it. And just like those highways need traffic signals and safety measures, an electrical system needs careful planning and safety precautions to prevent those electrical mishaps that can range from annoying power outages to dangerous electrical fires.
Right. A blackout is one thing, but an electrical fire is a whole other level of disaster.
Yep.
What are some of those key safety considerations that keep our homes from going up in smoke?
Well, for starters, all that wiring needs to be properly installed and protected to prevent those electrical shocks that can give you a nasty jolt or those sparks that can ignite a fire.
Right.
Circuit breakers are like those safety valves that prevent our electrical systems from overloading and overheating.
So they're like the circuit's guardian angels, stepping in to prevent an electrical meltdown.
Exactly. They interrupt the
Yes.
flow of electricity if there's a surge or a short circuit, preventing damage to appliances and reducing the risk of fire. And just as important as grounding, making sure those outlets and switches have that third prong that connects to the earth, providing a safe path for electricity to flow in case of a fault.
Right. Those three-pronged plugs aren't just for show. They're an essential safety feature that can literally save lives.
Absolutely. And let's not forget about lighting, which is often overlooked but plays a crucial role in creating a functional and aesthetically pleasing space.
So it's not just about flipping a switch and bathing a room in light.
Not at all. Lighting designers consider the purpose of the space, the natural light available, the types of light fixtures, and even the color temperature of the light to create the desired ambience and functionality. They use light to highlight architectural features, create a sense of spaciousness, or set a mood, whether it's a cozy living room or a bright and energetic kitchen.
Wow, it's amazing how much thought goes into something as seemingly simple as lighting.
It is. And it's a reminder that every aspect of a building, from the foundation to the light fixtures, is a result of careful planning, engineering expertise, and the collaboration of skilled professionals.
It's truly impressive to see how all these different elements come together to create those structures that we live, work, and play in. We've covered a lot of ground in this deep dive, from the fundamental principles of structural engineering to the complexities of plumbing and electrical systems.
We have, and I think it's important to emphasize one key takeaway: the importance of communication and collaboration throughout the entire construction process.
Right. Right. We talked about that earlier in the context of preventing those structural failures.
Yeah,
But it seems like that principle applies to every aspect of building a structure,
it does.
from the initial design to the final touches.
Absolutely. Clear communication, thorough planning, and a shared understanding of the project goals are essential for a successful outcome. Whether you're building a skyscraper or a small house, teamwork is the foundation for a safe, functional, and beautiful building.
Well said. And speaking of foundations, we've talked a lot about the technical aspects of construction, but I'm also curious about the human element.
Yeah.
What are some of the things that construction professionals should keep in mind to prevent those typical faults and ensure a smooth and successful project?
That's a great question. You're right, the human element is just as important as the technical side of things. Even with the best designs and materials, things can go wrong if there's a breakdown in communication or a lack of attention to detail. It's the human touch that can either make or break a project.
So it's not just about having the right tools and materials, it's about having the right mindset, work ethic, and a commitment to quality.
Exactly. One of the most common causes of construction mishaps is negligence in supervising the work on site.
Okay.
If those supervisors aren't paying close attention, mistakes can happen, and those mistakes can be costly to fix. It's like those cooking shows where a contestant forgets to set a timer and suddenly their beautiful creation is burnt to a crisp.
Ouch. That's a painful analogy, but I get the point. So it's all about having those watchful eyes on site, making sure everyone is following the recipe, so to speak, and that the construction process is unfolding as planned.
Exactly. And speaking of following the recipe, another common pitfall is incompetence of workers.
Okay.
This could be due to a lack of training, experience, or just a lack of understanding of the project requirements. It's like having someone who's never baked a cake before trying to follow a complicated recipe without any guidance.
Right. That cake is probably not going to turn out as expected. So, having a skilled and qualified workforce is essential for preventing those construction mishaps. But even with a team of expert bakers, so to speak, things can still go wrong if there's a miscommunication between the architect, the engineer, and the construction crew.
Absolutely. Miscommunication is like a game of telephone gone wrong.
Yeah.
The message gets distorted along the way, and suddenly you're building something completely different from what was intended.
Right. It's like that classic example of the architect drawing a door on a plan and the builder, not seeing the dimensions, builds a door that's only 3 feet tall.
Exactly. Those kinds of miscommunications can lead to costly rework, delays, and a lot of frustration on everyone's part. So what can we do to prevent these human errors and ensure a smoother, more harmonious construction process?
That's the million-dollar question. How do we make sure everyone is speaking the same language and working from the same sheet music?
Well, it all starts with communication.
Yeah.
Clear, consistent, and open communication between all the players involved, from the architects and engineers to the project managers, supervisors, and construction workers.
So it's about fostering a culture of collaboration where everyone feels comfortable asking questions, voicing concerns, and double-checking those details before they turn into major problems.
Exactly. Regular meetings, clear communication channels, and a shared understanding of the project goals are all crucial for keeping everyone on the same page. And speaking of being on the same page, a thorough review of those blueprints and construction drawings is absolutely essential.
Right. Those blueprints are like the construction Bible, guiding every step of the process.
Exactly. And it's important to take the time to carefully review those drawings, to ask questions, and to iron out any discrepancies or confusion before construction begins. It's much easier to make changes on paper than it is to fix mistakes once the concrete has been poured or the walls have been framed.
So it's like the old adage, measure twice, cut once. It's better to be meticulous up front than to try to undo mistakes later on.
Precisely. And finally, proper supervision of each phase of the construction work is crucial.
Yeah.
This means having experienced supervisors on site who are actively monitoring the work, ensuring that it's being done correctly, and addressing any issues or questions as they arise.
So it's about having those watchful eyes on site, those experienced guides who can keep the construction process on track and make sure everyone is playing their part in this complex orchestra of building a structure.
Exactly. By focusing on these key areas, communication, thorough planning, and proper supervision, we can create a more harmonious construction process, minimizing those human errors and ensuring that the final result is a building that is not only structurally sound, but also a testament to the skill, collaboration, and attention to detail of everyone involved.
Well said. It seems like the key takeaways from this deep dive can be summed up in a few simple words. Plan carefully, communicate clearly, and supervise closely.
Absolutely. And remember, building a structure is a fascinating blend of art and science,
Right.
where creativity meets technical precision. It's a testament to human ingenuity and our ability to transform ideas into tangible structures that shape our world.
We've covered a lot of ground today, from those foundational principles of structural engineering to those intricate details of building materials, construction procedures, and even the human element that plays such a crucial role in bringing it all together. And even though we've focused on buildings up to 3 stories high, many of these principles apply to those towering skyscrapers that grace our city skylines.
You're right. The fundamental concepts of strength, stability, and serviceability are universal in construction, regardless of the scale or complexity of the project.
Now that you have this foundation of knowledge about how buildings are constructed, we encourage you to keep exploring. There's a whole world of fascinating construction knowledge out there waiting to be discovered, from ancient building techniques to cutting-edge innovations that are shaping the future of architecture.
And who knows, maybe you'll be inspired to design and build your own masterpiece someday, putting those principles into practice and creating a structure that is both functional and a work of art.
That's a great thought. We hope this deep dive has sparked your curiosity and given you a newfound appreciation for the intricate world of building construction.
Until next time, happy building.